In this video, we're looking at inverse transformations. So for example, this transformation here, it's a horizontal dilation in a scale factor of 3. So if, for example, I did this to a point, 4,7, the x value would triple. So I would get 12,7. Now, you might be guessing, how do we undo this transformation? Well, you might actually want to take your x value and then divide it by 3. That seems to undo whatever this transformation does. And essentially what you can do to find the inverse transformation is just take the original transformation and do the inverse matrix. So this is something you can work out by hand, but we're just going to go into the calculator because usually it's a bit quicker to do that. 3001, and that's in matrix A. So if I go shift matrix alpha A to the power of -1, that gives me the inverse is a third 001. So there we go, a third 001. Now, this matrix, if you're familiar with dilations, represents a horizontal dilation, and the scale factor is timesing by a third. So yeah, that's the inverse. It undoes the original transformation. Next, we want the inverse of this transformation. It's a rotation of pi/6 anti-clockwise around the origin. So this is what a rotation matrix looks like: cos minus sine, sine cos. So we're going to go into this menu. It's a 2x2, and we're going to go cos of pi/6. Now make sure that you're in radians, which I am. You can get there from the settings menu if you're not. Minus sine of pi/6. Sine of pi/6. By the way, make sure you actually bracket the pi/6. I did have to redo this video because I got the wrong answers without having the brackets. Cos of pi/6. There we go. And then that's our rotation matrix. So I'm just going to say it's 0.866 minus 0.5, 0.5, 0.866. So I'm just going to call this matrix like R of pi/6, rotation pi/6. So the inverse is going to be this. It's just going to be whatever the inverse matrix is. So let's exit out of this menu. I'm going to go shift matrix A inverse, the power of -1. So those are all similar numbers to what we had before. So the 0.866s actually don't change at all. It's only these numbers which change: 0.5, minus 0.5, and 0.866. Now, if you're familiar with rotation matrices, you think, well, okay, we need a value where sine was negative and cos was positive. So this is going to be in the fourth quadrant down here. So this is rotating by pi/6. This is actually rotating by 11 pi/6. So rotation by 11 pi/6 anti-clockwise. But probably a nicer way to think about this is the original matrix was rotating by pi/6 anti-clockwise. So this is rotating by pi/6 clockwise. So the original one was anti-clockwise. The inverse is just clockwise. So if I want to do like a rotation of 40 degrees anti-clockwise, and I want to do the inverse of that, don't mind my very dodgy notation here, that will be a rotation of 40 degrees clockwise. So we've seen how dilations invert. So instead of stretching by 3, they just squish by 3, for example. How rotations invert, so anti-clockwise becomes clockwise. Or if you want, instead of going 40 degrees clockwise, you could go 340 degrees anti. That would be the same thing. Not 340, 320, because I have to add up to 360. And then I'd also encourage you to think about what the inverse of a reflection might be. How do I undo a reflection?